Hello to a very wonderful video concerning linear programming and how to make an optimal decision making. This data actually I got it directly from Excel. I need to give them credits because they really helped me a lot. ExcelEasy.com, and this is under the title Solver. So as long these people get their credits for the data, I'm in good shape. At least my conscience is clear. So what I'm going to go ahead and do, they presented the solution. I cleared all their solution behind the scene in order to really go through every individual step to make sure that you understand how to use the linear programming, of course, taking advantage of Excel. And I'm going to say it a little bit louder here, the solver feature, the add-ins solver, as I will show you how to add it and also how to use it effectively. In the Excel-easy.com, they didn't specify, the conceptual background of the problem. Mostly, they really do a wonderful job about the application side, which is basically I prefer that side myself too. But to understand, in this equation here, uh, it's actually depend on three variables. The first variable is x, y, z. X is representing the bicycle, and Y is the mopeds, and the Z is actually the child seats. And their profits is determined by the number of the bicycle they produce, also the number of the mopeds, and the number of the child seat. They have done their research. They found out that they make $100 profits if they sell from selling one individual bicycle. They make a $300 by selling one moped, and they make actually $50 if they sell one child seat. So that's where is this equation has been uh, created as a result. It's a function, sorry. It's 100x plus 300y plus 50x, the formula that we will be translating it into Excel. So if I do here 100 multiplied by x, 300 multiplied by y, and 50 multiplied by z, of course we know x is the bicycle, number of bicycle, and y is the number of the mopeds, and z is the number of the child seat. So we organize it this is the unit profits. Each is going to be associated neatly with the label, and in order to really produce the most possible profits, this is really where actually the problem should be aimed at, to maximize the profit. We always maximize the profit. We always minimize the cost. In this case, the formula is based on profit, so that's what is our hope, is to create a higher, the most possible profit, which really the keyword optimal, that's what it means. In order for us to do this, we have to be subjected to a few constraints. For example, a constraint, really a situation that is imposed on us through the production of these three items: the bicycle, the mopeds, and the child seat. It will take actually $300 to produce the capital to produce one bicycle, $1,200 to produce the mopeds, and $120 to produce the child seat. They have the total budget for this project is $93,000, which means when we do actually produce the number of the bicycle, the number of the mopeds, the number of the child seat, the total of all the costs associated with the production should be less than or equal to this amount. We don't have an infinite amount of money. That's basically when we do any economics analysis, we always have to deal with the concept of scarcity. That's the heart of economics. Actually, economics is defined as the science of scarcity, or the social science of how to deal with the scarcity in order to meet our wants and needs. And this is an example of that we don't have really $3 billion or $3 trillion. That's the maximum amount of money that we have to use. So in order for this later to become really viable, it has to be either exactly the same amount, $93,000 or less. The same thing, we have the storage area in order to store whatever we manufacture, because we don't have unlimited field or warehouses. It takes point 0.5, let's say, square yard or square meter to store one bicycle, and it takes 1 square yard to store mopeds, and half a square yard in order to store the child. So the total of the storage area also should not exceed 101 square yards. So it should be less than 101 for this one here. The model, what we're going to be doing is to determine the number of the bicycle, the number of the mopeds in the child seat based on these constraints here, and to maximize this here, which is the total profits. So we will actually do trial and errors in order to see how it's going to work. Then eventually we're going to go ahead and use Solver in Excel in order to show us what would be the best possible solution. Before we do anything, I have to do some calculation, and we need to give our attention completely to how things are going to be used here. There's a lot of shortcuts. That's why we're using Excel. Excel, a tool to make our life a lot easier, a lot more efficient. So efficiency is really by seeing how we could use some of those functions that build in Excel, so we don't have to really spend our age trying to do things manually or calculating it in an efficient way. So how do I, for the model to calculate this amount, where it should be less than 93,000, I have to multiply this by this, plus this by this, plus this by this. So I could do it like this, and I'm going to go ahead and take my time this time. In future videos, I'm not going to do it because I'm going to teach you a function and how to do it very quickly. So this is going to be multiplied by this, plus, see how I already start to take a lot of time. This is multiplied by this, plus this is multiplied this. I cannot really reach that cell, which is supposed to be now E11. So E11 in this case. And notice it's giving me 39,000 based on what I have multiplied it here. So multiplied this by this, multiplied this by this, multiplied this by this. Basically, if I wanted to multiply it, I'm actually doing the wrong calculation. I'll give you quickly what I'm doing here. I'm explaining a concept, but in the solution, it's really not to multiply this by this, or this by this, or this by this for the sake of the problem. Is to multiply this by this, but that's going to result into 0. So let's go ahead and see that's how we could do this as an on-site example, just to explain to you how we're going to get 39,017 in the same way that we've done it in multiplying this by this, this by this, this by this. I'm going to go ahead and take this out completely, the cell, and I'm going to show you there is a function, it's called sum products, which is going to take all this, okay, comma with all this. Okay, so we could easily see and hit enter, and you're going to get the same calculation here that we've done before. So it's 90,000. Let me see here. Maybe it's a little bit different than the previous one, but I'm going to go ahead and see if that is the case. I'm going to go ahead and undo. We got 39,070 when I did that. Let me see if I really doing the right. So it's C17. I already probably made a mistake because I didn't use the sum product. So this multiplied by this, D11 multiplied by D8, and E8, which is, in this case, is here multiplied. You see here, I already did the mistake of adding instead of multiplying. That's why, see, when we do things manually with what we call the fat finger syndrome, meaning I'm doing the typing myself, it's going to get me into problem. Anyway, we'll learn now how some products is working. In order for me to get the model to work, of course, I don't need to multiply this by this or this by this or this by this. I need to multiply how much it's going to cost me to produce the number of the bicycle based on the number of the bicycle, because each bicycle is going to cost me $300. So the summary product is going to be this way here. It's okay to make a mistake while we're explaining things. It's going to be this one here, okay? And I'm going to actually use this, but I'm going to lock it by hitting the F4. Why is that? Because I'm going to be multiplying the capital with the number that the model is going to create for me. But I'm going to be using the same calculation for the storage. So it's good to really lock the number of the order or the order size and reuse it with the, okay, I did mistake here. Let's go ahead and undo, or maybe I shouldn't be. Here we go. Here we go. That's it. Hit F4. And notice I'm going to get 0, of course. Any empty cell is 0. But notice I'm using the C11 multiply by E11 and multiply for this. So that will give me the courage to go ahead and drag this down. Drag this down. Of course, I'm going to get 0 also, because this is going to be multiplied by this. This is multiplied by this. This is multiplied by this. And I add all the multiplication, which is done for me directly with the sum product. Sum product's way too powerful of a function that we should not neglect using it every time we have many pieces of data that needed to be multiplied by another range equal to it, and those multiplication need to be added. So, okay, I'm trying to avoid making mistakes. So, and here we go. We had done this. We've done this too also. Now it comes to the total profit. The total profit, first of all, let me go ahead and show you that the total profit is going to be this number of item multiplied by the profit that I generate from each one of those items, which is this function basically. This one here is going to be this one here, this line here, and this here is going to be this here. It's very easy to convert it into an Excel, and this is what we are solving for. But we will play with it before we even run the solver. So we're going to go ahead and say, okay, the total function is going to be the sum product, which is this, okay, that's here, and going to be multiplied by this, okay? I could easily, lock this here, but there's no need. But just for the peace of my mind, I always lock the the number of the items that I'm actually using the model to solve. Here we go. We ended up with 0 profit. So let's go ahead and test it before we even run it. Let's assume that we produce 7 bicycle and we got 8 mopeds, and we ended up with, let's say, producing 900 seed. Okay, our profit is 48,100. We still under the constraints. However, look here, we already exceed the limits of the storage, so this is not going to be a good solution for us. Also, the profit maybe is not the highest possible. So if I change this to, let's say, 80 and reduce this to 9, this is not feasible also, because I exceeded the amount of money that is allocated, even though the storage is okay, and my profit immediately dropped. So this is not going to work. So I could go ahead and spend a month trying to figure out what would be the best possible solution where I'm still dealing with my constraints and also maximizing the most possible profit. So this is what I'm going to show you in a second. First of all, you could leave those here. I don't care. We shouldn't care, because the model should be able to adjust that to you. Or you could go ahead and put all these zeros and expect that also the model to do the best possible outcome. But we did the trial and error just to show you that everything is responsive, just to make sure for the peace of our mind that if we do actually do anything with those data here, this is going to be alive. This is a live formula and this is alive. So we would not have a problem when we run the model. And we need to think this is as a result of this multiplied by this. We use the absolute address to lock it. So we are able to use this multiplied by this, and that's where the result is stored. Total profit is the unit, the coefficient of the original function equation, and multiplied by, I don't know, you could call it function and equation. The difference between the two function always return one value. Equation might give you more than one value. In this case, I'm going to call it function because I'm going to get only one value. When you didn't teach math for too long, you get confused about some concept here. So let's go ahead and continue with this. I'm going to put this right here because that's what I'm solving. And I have to really make sure that this is going to be a maximization problem, not minimization problem. Because you will see when we activate the solver, it's going to give you three options. First of all, if you don't have your solver in the data, a data ribbon, it's right here, so I already added it. But you could go to a file, just like we did in the data analysis, go to the options, and make sure that you click in on the add-in. Okay, click on it. And right here, you could click on go, and you see is the solver already been checked. If I unchecked it, it will be removed. If I checked it, it will be there next to the data analysis. So I'm going to leave it there because I need it. And if you don't have it, this is how you're going to add it. Let's go ahead and see how we're going to do it. So I'm going to click the solver. The solver maybe had a previous problem from the past. So I'm going to go ahead and take that out. Here we go. And this is what I'm trying to solve for. I need to make sure this is a critical moment in your solution, is to make sure that the max is the one that is selected. Don't select minimum, don't select value of, meaning like sometimes you want to look for a solution that exactly that number. So we're looking here for maximum. By changing the cell, which really those the one that you're solving for, which is here. That's right here. Okay. I'm going to go ahead and delete the constraints, delete those, and create them with you together. So we're going to go ahead and start by add. Okay. The very first constraint is this. Okay. And we have less than or equal, greater than or equal. Later, we might get to, maybe not in this class, in a future classes, if we ended up teaching a class to continue with the decision making. We'd use integer linear programming, which require really a harder calculation, binary, of course, and def. Those are very, very helpful. And we're going to go ahead and the constraint, and based on this one here, is going to be this one here. I cannot exceed that one. And I'm going to add, and this is the second constraint, and it's less than or equal. And I'm going to go ahead and the constraints, no, something here. I made a mistake again. Well, I'm glad I did. I'm going to say cancel, take that out, delete. This is not the one I should select. The add, it's supposed to be this one here, less than this one here, because that's where is the calculation. And to be honest with you, because both of these here are less than or equal, I could actually save myself a step by selecting both of those in the constraints, and also could go ahead and select both of those. So if you have really multiple greater than or equal, or less than or equal in this case, just select them all at once. So, but actually make sure that the range is equal. So this is end up with G12. This should be end up with I12. And make sure this is what we are trying to solve for. And I say, okay, because I don't have any more constraints. Okay, I don't have any more constraints. Maybe the constraints is going to be greater than or equal to 0, because we have to get something physically So it has to be greater or equal to 0. So I'm checking here, make and constrain variable non-negative. So this is, we used to put that kind of constraints inside the model. Now we have it as an option directly in Solver if you have Solver 10 or Solver 2013. 2007, if you're still using it, it really doesn't have all the full functionality that we have. Solver has tremendously increased with its capability with 2010, Excel 2010. Make sure that you leave it at Symbolics LP linear programming. We have used the GRG nonlinear when we did that into the nonlinear regression before. So I'll leave it as a Symbolics, and I don't need to change anything. I might have one day go ahead to change by creating the number of the iteration, like to give it like 1,000, which is really going to iterate more, looking for a better solution or more optimal solution. I could go ahead and change it now, or you could leave it. And now we are ready to go ahead and solve it. We're going to solve it, and notice that again one more time, just in case, this is going to be the total profit by changing the variable cell that cover those 3 cells, the constraints here, and make sure you don't get lost. Like I did get lost a couple of times because I'm recording and talking and looking. Is to take those 2 cells that has the formula or function sum product behind the scene. They should be less than or equal to this, because we already have the sum product, those coefficient here multiplied by the number. So everything need to be calculated is behind this 0, which is the, and also everything has to be calculated regarding the storage is behind this 0 here. So go ahead and click solve, and hopefully this number will be the maximum number, and those will be utilizing also the maximum utilization. I don't know if you heard in economics when we talk about the production, the production, the PP curve, the production curve, where we actually wanted to get that maximum possible of production. We want to be all within our own resources, so we don't want to really go below, so it will be inefficient. And maybe sometimes we cannot go beyond what we have because we don't have the means. So that's basically what we are talking about. Solve, and here we go. It gives me, let's take a look at this. The profit is 25,000. I'm going to go ahead and accept this. And notice that very, very efficiently, we use all the resources money-wise, and we use everything has to do with 101 when it comes to the storage, and we were able to produce $25,600 in profits. And look here also, actually this is a different formatting, so I'm going to go ahead and force it to be currency. And look here, that we ended up, or we should be able to produce 94 bicycle, the moped 54, and it's extremely inefficient to actually produce anything with the child seat in order to maximize our profits. So I'm gonna take a mental shot of this. I'll go ahead and change it in a second, but if I change this to 3, for example, and I hit enter, we already exceeded this limitation and this limitation, and this is of course going to produce higher prices, but we don't have the money to produce those 3. But what about if I took 2 of those, because the moped is more expensive? What will happen? Notice immediately things change to this became 30,000. If it was, let me see how it was, 54. Let's go ahead and say 52. Okay, not 2. And we did not really utilize all the resources, but that's could possibly in future problem. We cannot use all the resources because it doesn't make sense. But in this model, according to the solution that we got, it really made it possible to use everything, and in order to maximize this. So I don't want to play with this anymore because I'm happy with the result that the model did produce the most efficient result based on the fact it used all the resources in order to maximize the profit. I could go ahead and select this one more time, go to data, if I did get lost in the process to where I am uh, thinking here I need to go ahead and solve it again, accept it, and it restore everything to how it was. And we're going to stop here, and we're going to continue with the next videos concerning with something really powerful as a decision maker, which is the sensitivity analysis. We want to look at the data and what they mean so we could have a very solid interpretation of how things really should be done, just in case we wanted to change our mind about certain things. That is going to be the next video. I really apologize about the length of this video, but it's very critical for us to know this type of information. Here's Dr. Sam Hijazi. I wish you a wonderful day, and I hope to see you in the next video. Have a great day.